Okay, today you're going to be learning about how to count atoms in chemical formula again, but this time we're going to be modeling the chemical formula, and we'll be modeling an equation. Okay, but first of all, let's take a look at the chemical formula. On an activity like this, remember, at this point you don't know which element comes first in the chemical formula. Bryn, I forgot you asked me a question. What did you need? Okay, after we're finished here. Okay. You don't know what letter comes first in the chemical equation, or the chemical formula. So at this point, as long as you're getting the subscripts right, you're doing okay. Once you get to high school, you'll learn the rules about which element comes first. Now, yeah, so if you got them backwards, that's okay. So the first one, everybody should know CO2 at this point. Somebody tell me, what is the chemical formula for CO2? Carbon dioxide?
CO2.
Yeah, CO2, I just said, okay. And the next one. Now, on this one again, you don't know if aluminum comes first or chlorine comes first, and as an 8th grader, you don't need to know that yet. Okay, but you do need to be able to recognize the subscripts that go with those. Farah, what did you write down?
AlCl3.
That would be right. AlCl3. Now, because I gave you the names, you should have been able to figure out which one comes first. Okay, aluminum chloride. So we know aluminum comes first. So given that information now, given the name, iron oxide, which one do you think comes first?
Fe.
It is Fe. It's Fe what, Jason?
O3.
Yeah, Fe2O3. Very good. Any questions about that? Okay, get your science journal out and put that in the warm-up folder. Today we're going to be looking at, remember tomorrow you do have a quiz, so make sure you study vocabulary.
Yes, sir.
And you need to know where reactants are, where the products are, what the arrow stands for. Does anybody remember what the arrow stands for? Yield. You'll be able to need to tell me what a subscript and a coefficient are. You'll need to be able to count the atoms, like we've been practicing doing. Okay. Today we're going to model chemical formula and chemical equations. So you need your booklet on page 27. Go ahead and open up that booklet to the next page in the booklet. And it's going to be the page where it says, yeah, modeling chemical formula. We're going to model chemical formula first. And then where it says modeling chemical formula on the right side, I actually have a sheet that we're going to use instead of that page. Okay? Now, there's a key up there. It says white is hydrogen, so you're going to need some colored pencils for this activity. Blue is nitrogen. Everybody read those colors and grab a colored pencil according to those colors there, please. If you don't have enough colored pencils, come over here and grab some more. Grab a handful. Put it in your box. Okay, now, on this activity, you're going to use those colors, and you can just lay the colors out in front of you, or y'all can share them. In this activity, you're going to be coloring the blocks based on the key at the top. So, for example, the top one that you have, everybody's going to do this one, it's CO2. What color is carbon according to your key?
Black.
Black. So, how many carbons are there? So you color one of the blocks black. You color one of the blocks black. Okay. How many oxygen are there? Let's go ahead and use this one, because all the sharpeners are in Miss Barton's room, and I don't have time to remember it. How many oxygen are there in CO2?
2.
So how many boxes do we color red? 2. Okay, I want everybody using that information then to do the next one on your sheet. ZN NO3 2. The first thing you need to do is what? Listen, the first thing you have to do is count the atoms. Okay, so everybody get those pre-colored, and then we're going to count the atoms on this one together. Somebody tell me, how many ZNs are there?
9. 1.
There is 1. So write a 1 above it. Remember how we did that? I'm going to do it on the board over here. Okay? First thing you're going to do is count the atoms. Okay, somebody read that off to me. It's ZN parentheses. Okay, so step 1. We have to put 1s where there aren't any. So there's a 1 here, here, and here. Next step, what do we have to do to these parentheses? Yeah, we have to get rid of them, so we times by 2. 2 times 1 is?
2.
And 2 times 3 is?
6.
And now it's gone. Then 1 times 1 is?
1.
1 times 2 is?
2.
1 times 6 is? So now we know there's 1 ZN. So what color is ZN? Z? Green. So everybody grab a green and color one of them. Did that work from yesterday? Okay, so how many zincs are there?
1.
Color it green. Okay, the next one, nitrogen. How many are there?
2.
What color is nitrogen?
Blue.
Grab a blue and color 2 of them blue. How many oxygen are there? 6. What color is oxygen?
Red.
Color 6 of them red. Do you understand how you're doing this? Okay, everybody's going to do the next one. Now, please notice on the next one, it has a coefficient in front of it. What does that coefficient tell us? There's 2 of them. Okay? There's 2 CO2s. Okay? There's 2 CO2s. I'm going to see if everybody can do this right. What I want you to do is color it lightly, the third one. In case you make a mistake, I want to see if you can do it. Color it lightly so you can make changes if necessary. You did perfectly. That's exactly right. People mess it up. Okay. Try the third one. 2 CO2. Okay, on this one now, I did it up there. How many zincs are there? 1. Okay. Color the third one lightly in case you mess up. Now. Okay, because remember this tells you this 2 and 1 says you have 2 of the same thing. Okay, so you have 2 of these. So you see how it should go now? That's exactly right. Okay, you're doing it right. You can finish coloring. That is right. Finish coloring it right. See? Okay. You want to go get it? Okay, listen. Remember this? Yes, what would you do? This that you have to do. You have to do this. That's it. You have to try. We're going to get this class to try. Perfect. Okay. you have 2 CO2s. What did 1 CO2 look like? This tells you have 2 of them. Okay. Well, you have to be careful because that 2 in front tells you you have 2 of what you have at the top. Okay, you see the one at the top? Let me see what you got. Okay. This is very confusing. Okay, try it and I'll come back and tell you what you got in your bag. That's right. Okay. No. Okay, what this 2 in front tells you is you have 2 of those. See the CO2? You have 2 of them. Try again. That's right. Can I see yours, please? Can I see? Okay. That's right. Okay. Now it's right. Now you have it right. Okay, that's not right. You have, yes, you have 2 of what you have at the top. 2 of them. That's it. You understand it now? Okay, remember, this 2 in front tells you you have 2 CO2s. There's 1 CO2, so you need another one. Okay. That third one was a little tricky. I'm going to draw it up here on the board. I think everybody has gotten it now. Remember, if you have a coefficient other than 1 in the front, so for example, 2, that means you have to have 2 models of the same thing. 2 models of the same thing. So for this one, you would have had 2 like that. 2 of the same thing. 2 CO2s. Okay? What if this had been 4? Then you would have had 4 models of the same thing. Does everybody understand? Okay. Today's activity, you're going to be modeling, and I'll give you a note just a second. Chemical. Here are the colors you're going to use. So you can go ahead and close your booklet up because we're not using those colors anymore. In this activity, you'll be using the colors on the screen. This time, not only will you be doing individual formula, but you'll be doing entire equations. And I'm going to do one of these with you. Remember, chemistry is about equations, not just formula. And then you'll have 3 to do on your own. This isn't lab grade. It should be an easy 100. We're going to go over the answers. Lane, just go ahead and go. So I'm out of notes. Okay. No. Oh, I gave you lots of them. Mr. Clump's having a bad week. Okay. So, using that key up there, I'm going to pull this up on the screen. So everybody pay attention. I'm going to show you, yeah, that's going to be up there when you were doing this, but I'm going to show you this for now. Okay, let me look back real quick to see what colors we're going to be using. Carbon is going to be white. Okay, so you'll need a white. And oxygen is, it's a purple. So you need to grab a purple, right here, oxygen, and a white. Okay, those are the ones we're using right now. Purple and white. Okay, so for carbon, block. Because it's just, how many atoms there?
Wow.
There's just one, so we need one block. And let me find a pen that writes. Carbon is what color, did I say? White. So I'm just going to leave it white. Okay? Oxygen, how many are there? So how many blocks do I need? And what color were they? Purple, so you would color them purple. See if I can find a purple here. No? Yeah, anything you need sharpened, you can sharpen in the electric sharpener over there. So we need 2 purple blocks. Now, how many blocks total do we have on the reactant side?
1, 2, oh wait. 1, 2, 1, 3.
3. Everybody look up here a second. How many blocks total do we have on the reactant side?
3.
So how many blocks are we going to need on the product side?
3.
We're going to need 3. Okay, so on the product side, let's look at it. How many substances are there? How many substances?
3.
Substances, not elements. Substances. There's 1. So all of your blocks are going to be connected. How many do we need? 3. One of them is white and 2 of them are purple. So here in this chemical reaction, carbon and oxygen will come together, added together to form carbon dioxide. Now, number of atoms. How many total atoms are here? Write a 3 there. How many total atoms are here? 3. How many of you remember I told you the arrow could also be what? Equals. So 3 is 3 equal 3? And you've done it right. Okay? Now, in all chemical equations, all of the atoms in the reactants equal the atoms in the products. So every time you're doing this, how many you ever draw here, you have to draw here. Okay? Now, how many different sets of blocks did we draw here?
3.
Different sets.
Oh.
2. Because how many substances did we have? 2. How many substances here?
2. 3.
I don't know why you're still getting confused with this. We need to go back and relearn this. Okay? How many substances are here? 2. Because they're separated by the plus. How many substances are here? 1. Okay? Only 1 substance, because there's no plus sign. Okay? So we have 1 set of blocks here. Okay, let's move up to the next one, and I'll put the key back up for you. I want everybody to draw this one. There's your key. Copper is going to be pink, so you'll need a pink. And oxygen, again, is purple, so you're doing pink and purple. Please look at your product. What is at the front of your product? A 2, a coefficient. So how many sets of blocks will you need? You'll need 2 sets of blocks, like in your practice. Well, how many? Yeah, there you go. That's exactly right. But here they're going to be doing what? They're going to be together. They're going to be touching because they're bonded. So you draw 2 like this that are touching. There you go. Well, now you have 2 sets of copper and oxygen. How many together? 2. So you need a set of 2 and another set of 2. You see how to do it? Uh-huh. Well, know that they're not bonded together. They're separate. Okay, should not be touching. They're not bonded together on this one. This one they are because it's a subscript. This should be like in your booklet, 2 different sets. These should not be touching. Mr. Miller, they shouldn't be touching. They're not bonded together. It's 2 different molecules. Okay? So for 2Cu, They should not be touching. Like this one's perfect. Good job. Now, you have too many here though. You only have 2. You have 4.
There you go.
Okay, let me go over this again. Yes. Let me go over this on the board. Everybody just watch real quick. That's right. Yes. Okay. When you have something like 2Cu, those are not bonded together. So that would be like saying you have 2 of them. And they're separate. Everybody look up here. Okay? Now, when you have something like O2 with a subscript, those 2 oxygen are what? Bonded together. So here, those 2 would be touching. Okay? Because they're bonded. Here, they're not bonded. They're 2 separate things when there's a coefficient. Okay? Let me see if you've gotten this right. Okay, that's right. Now, on this one, you have 2. You're going to have to do. Yeah, but 2 of how many? How many boxes do you have here? No, you're right. This is right. So how many boxes total do you have here? How many boxes total? 4. So how many do you have to have over here? You have to have 4. So you have 2 sets. You don't have 2 sets of 4 because then you have 8. You have 2 sets of 2. There you go. Now look at the formula. You see how that works now? One of those boxes is copper and the other one is oxygen. That's exactly right. You see yours? Okay. This is not, they shouldn't be touching. Okay. They shouldn't be touching. They are. These 2 are bonded. So you should have a pink and a purple together. And then another pink. These should not be bonded. They should be separate on like these. Okay. Okay, great. That's right. This is not right. Because you have 2 here. You need one though. You have how many are there? 1, 2. So you should have 2 blocks. And then you should have 2 of those 2 blocks. Okay? They should be touching. When there's a subscript, those should be bonded. Okay? Now you're getting carried away here. Pretend that's not there. How many atoms are there? 2. So you need a box of 2. Yes, they have to be touching because it's Cu. Oh, so that's 1 substance. Okay. Now, the 2 in front tells you have how many of those? You can draw another. Okay, this isn't right. You have them all bonded together. Okay. Pretend like this isn't here. How many atoms do you got? 2. And then that tells you have 2 of those atoms. Okay. Look at Paris here. You should have 2 sets of those. Just like on the other one we did in practice in your journal. Okay, this is right. Good job. Okay. That is right. You should have 2 sets of those. And they are bonded together, so they need to be touching. They need to be touching. You're silly, you're right. Good, good. Because C and O should be bonded together. Yes, they should have to be touching. Okay, let me go over this again. Y'all are still not catching on. Look at this one we did together, the CO2. CO2, everybody pay attention. How many atoms are there? How many atoms are there?
2. 1. 4.
How many atoms are here?
4.
How many carbon?
1,
How many oxygen?
2,
For a total of
3.
3. So we needed 3 blocks there. Because this is a one formula, all the boxes have to be touching because they are bonded together. Okay? So we have 3 boxes. Now, if we put a subscript in front of that, that means we need 3 of those. And there it would be. So, for on this one, it was 2 CuO. Just pretend like this 2 isn't here for a minute. How many atoms do we have here? 2. Everybody pay attention. We have 2. They're touchings. This is one formula, so those 2 are what? Bonded together. Okay? Now, it does say we have a coefficient in front. That tells us we have 2 sets of those. Okay? So in that third box, it should look like this. That was the first one. Yours should look like something similar to this. Okay? If you didn't get this, draw it now. We have 2 copper. Notice that, why are they separated? Because we have a coefficient here. That coefficient tells us we have 2 of something that are not bonded together. Okay? Here, why are they touching? Because it's a subscript, and that tells us they're bonded together. Okay. Here, why are these separated? Because of this. It tells us that that formula, there's 2 of them. Okay? Yes, sir. It could be, you could do it sideways, it doesn't matter. Those could be rotated on the side, or they could be, the pink could be at the top, the purple could be at the bottom, it doesn't matter. Okay? Now, what's the total number of atoms on this side?
3. No.
1, 2, 3, 4. So how many should be on this side?
4.
And there are. Okay? Let's flip your page over and do the next one, please. There's your key. Oh, let me go back. There's your key again. Yeah, do you have 2 of the same thing there? No, you didn't. You had all purple and all pink. Are those the same? No, because these are purple and pink. They're not the same. They had to be. Yeah, but you have to color it. This is right. Iron is, chlorine is black. Calcium would be orange. And chlorine is green. Yeah, you got that right. Why do you have these separated? That is one formula. They all keep touching. That's right. And that's right. It's up here. Here's your sheet for today. When you think you have this one done, raise your hand. I'll come check it. Chlorine, I think, is supposed to be black. And there should have been 2 of them bonded together. Okay. How many CAs? How many CLs? No, they're not. This is one whole formula. There, how many chlorine? You only have one. Okay, this is right. Now this is chlorine. Okay, you have it drawn correctly now. It's colored. Why are these all? They're all that's bonded together. One formula. They're all together. Okay, how many F's do you have? Is that 2 of them there? Okay. You have it right. Yes, sir. Count your atoms now. You didn't count your atoms. Okay, that is right. Okay, that is right. Are they bonded together or are they separate? Remind me those we need to go. How many F's should you have? Is that 2 or 1? Okay. That's exactly right. Make sure you right now, number of atoms. How many atoms?
Is it broke open?
1, 2, 3. Plus 1, 2 is how many atoms? How many atoms? Count them. Count the boxes. Yes. How many on the other side? Okay, that is right. Okay, how many atoms do we have here? That's called calcium. We have a total of 3 boxes. They're all going to be touching because they're substance. There's no coefficient. If there's a coefficient, then you're going to have something more touching. Okay. And chlorine is supposed to be black. This is right. We'll check this one in a minute. That's right.
Is oxygen blue?
Oxygen is purple. If you use blue, that's okay, but it's purple. Okay, I've checked most people, so let's take a look at what it should look like. Again, let me put this one up first, and let's just go over this real quick. Everybody look up here. On this one, is there a coefficient?
No.
Everybody look up here, please. Stop and look for a second. Everybody, I'm waiting. Alexa. Okay. Is there a coefficient here? No. So everything here is going to be bonded together, so all your boxes are going to be touching. They're all going to be touching. We have 1 calcium and how many chlorine?
2.
For a total of 3. So you need 3 boxes touching. One of them is calcium. What color was calcium? Orange or red. And this chlorine, I think, was green.
Light green.
So you should have had 1 red and 2 green. Fluorine, is there a coefficient here?
Yeah, no.
No. So these are going to be, the boxes are going to be what?
Together.
Together. So you should have 2 boxes. And fluorine, I think, was black.
Dark green.
Or dark green. It looked like it was black to me. So this is what this one should have looked like. Okay? Now, again, the order of the color doesn't matter. As long as you have an orange and 2 greens. The orange could have been at the bottom, the orange could have been at the top, it doesn't matter. Okay? 2 blacks. Then on this one, we have a calcium, orange, and 2 fluorine. And then plus 2 chlorine. Again, the reason these are touching is because it has a subscript, not a coefficient. The reason why all of these are touching is because there's no coefficient. This is all together, one substance. Is this one substance? Yes, because there's no coefficient. Is this one substance? Yes, so it's just one model. Okay? I'm going to put the colors back up.
Mr. Bump,
Okay. Everybody do the fourth one, please.
were you supposed to put the numbers on? For that, how many atoms?
Yes, and it should have been, oh, sorry. Everybody do the fourth one. If you're done, raise your hand, I'll come check it. That's right. The only thing is you didn't count all your atoms. To get full credit, you have to count all your atoms. And it should start
What
from
color
the
is
bottom.
sodium? Brown?
Brown. Sodium is brown.
I'm doing it like that.
Make sure you're counting your atoms for your grade. Okay, how many atoms you have? Oxygen is, I think, purple or blue is fine. Why are they not touching? Do you have a coefficient? That's all one substance. They all should be together. They should all be together. You add them together, so it's a total of 3 or 5. Yeah, I'm coming in a second. They all have to be touching. You're happy with it? They're all together. There you go. Yeah, you got your hang up now. Make sure you have all your atoms counted. Everything's colored. And the bottom must be in. Unless you want to wait to see the answer. Come up with the answer. Okay, you haven't been counting the atoms either, so make sure you keep that before you go. Why are these not touching? Is there a coefficient there? No, they should all be touching. There you go. All one substance. You're understanding it? Right? All right. Okay, good job. Oxygen is purple or blue.
Yeah, I know, what's so pretty?
I'm going to show that last answer when we go over it.
It should be there.
Is this right?
Well, is there a coefficient?
Oh, no.
They're all together.
Hey!
Is there a coefficient? No, so they should all be touching. You're getting the answer now, right? Okay, I'm going to go over that last answer again. Very good, you understand? Okay. Let's go over these answers again. On this one, the first one, if you want to turn back to that page, make sure you have this all correct. Remember, there are no coefficients here, so there is only one substance, one substance, one substance. So there's going to be one model, one model, one model. That would only change if there is a coefficient. So carbon is 1. O2, that means we have 2 oxygen and they're touching because they're bonded together. Carbon dioxide, this is all one substance, so they're all going to be touching. Carbon and 2 oxygens. How many atoms are over here? 1, 2, 3. How many are here? 1, 2, 3. Okay? Next one. On this one, again, the reason, somebody tell me, why are these two separated and not touching?
Because it's two different sides.
Yeah, there's a coefficient here. That tells us how many little blocks of models we will have. We'll have 2 blocks of models. It's just one copper. So there's one copper and there's one copper. So make 2 copper. Okay. These, why are they together?
Because it's one substance.
It's one substance and they're bonded together. Okay. Why do we have 2 here?
Because they're two different.
There's 2 different things. Well, it's the same substance, but there's 2 of them. Okay. So we have a CO and a CO. 2 of them. Okay. We have how many atoms here? 1, 2, 3, 4. And we have 1, 2, 3, 4. This is going to be really important come Friday when we are talking about the law of conservation of mass. The law of conservation of mass says that the number of atoms on the reactant side must equal the number of atoms on the product side. Okay? Let's look at the next one. Okay, on this one, calcium chloride, 3 atoms, so we have 3 blocks. They're all touching because this is one substance, and there's no coefficient. No coefficient here, so it's 1 block. Together, we have 2. Here again, this is one substance. There's no coefficient. No coefficient, so they're together. Okay? The last one, and again, the number of atoms there, 5 and 5. NaOH, this is the way this one should have looked. Again, the blocks are up and down. You might have drawn them sideways. That's fine. We have 1, 2, 3 elements in this substance. Here they are bonded together. We have 2 elements in this substance bonded together. We have 2 elements in this substance bonded together. We have 2 elements but 3 atoms bonded together. Okay? If you're happy with your work, everybody should make 100 on this, put it in the box.